about probability and just really briefly cover some vocab. So probability is something that you may have heard of before, like what is the probability that I'm going to win this game or get a good grade on this test. Today we're going to talk about probability just kind of as a whole. So probability has a lot of like really heavy vocab, so I want to talk about that for a minute. So we have trials and probability. Trials are just every single time you do something. So if I'm looking at a single trial when I'm rolling dice, that would just be rolling the dice one time. That would be one trial. The outcome is what happens during that trial. So if I roll a dice or a die and I get a 1, that would be my outcome of that trial. Next we have experiment. So our experiment was just something that we kind of conducted in our heads. Well, okay, so if I'm rolling a die, what is going to be my outcome? That is the experiment. Your sample space is just all of the possible outcomes that you could get. So if you're rolling a 6-sided die, you're either going to get a 1, 2, 3, 4, 5, or 6, right? There's no other options. That is your sample space. Your probability, that is just your chance of getting something. The chance of getting a 1 if you're rolling a 6-sided die, or the chance of getting heads when you flip a coin. That would be your probability. The event is kind of the same thing as the experiment. So the event would be rolling the dice once, or rolling it 50 times, or rolling it 100 times. A simple event is just one where you're only doing one thing. So you're only looking at rolling one die, or you're only looking at tossing one coin, or pulling out one marble, not looking at several different things altogether. So those are just some of our basic vocab words. It's going to be a lot heavier here in the next few minutes. There's going to be a few more vocabulary terms added on, but we're going to start with that. So I'm going to erase some stuff to give myself a little bit more space here. Now I want to look at our formula. So when you're looking at probability, you're always going to come back to this basic formula. So to find the probability of any event, you're going to say, well, how many times can the event occur? So if I'm rolling a 6-sided die, it can only occur probably just one time, maybe 2 or 3, I don't know, it kind of depends on what we're looking for. Divided by the number of possible outcomes. So let's kind of get a feel for this. What does this look like? So let's say we're trying to get a 3. I'm really wanting a 3. Okay, so we write that as P for probability with 3 in parentheses. Okay, so now we're going to say how many times can the event occur? If I'm doing this just once, how many times can it happen? Well, it can only happen once, really. But how many different 3s do we have on here? There's 1. There's only 1. There's only one 3 on a 6-sided die. So you're going to set that equal to 1 over, or divided by, the number of possible outcomes. Well, how many different outcomes are on there? On a 6-sided die? Well, there's 6. There's 1, 2, 3, 4, 5, or 6. So your probability of rolling a 3 is 1 out of 6. Does that make sense? I hope so. Now let's kind of look at a more complex problem. So let's say we wanted to get an even number. So we're going to write it as the probability of an even number. Well, we know that 2, 4, and 6 on a 6-sided die, those are all even numbers. So if I roll, I could get a 2, a 4, or a 6, and those are desirable outcomes. Those are outcomes that I want. So there are 3 of them. So the number of times it can occur, there are 3 possibilities. So I'm going to put 3 on top. I still have my division sign. That hasn't changed. And the number of possible outcomes, well, there's still only 1, 2, 3, 4, 5, or 6 that I could ever possibly get when I'm rolling a dice. So it's going to be 3 out of 6. You could also simplify that to 1/2. You could write it that way as well. So about half the time when you're rolling a dice, you should get an even number, a 2, a 4, or a 6. So what about the times that I'm not getting an even number? So I've rolled it and I'm not getting evens. Well, what's the opposite of even? So the opposite of even is odd. This is something that we've known for quite a while. So if I'm not getting evens, I'm getting odds. So what are the probabilities of getting an odd number? Well, that would be 1, 3, or 5. So that's three possible times it can occur. So I have 3 out of the number of possible outcomes is still the same. It's 3 out of 6. So you're saying half the time I'll get even, half the time I'll get odd. That's interesting. Can I get anything other than even or odd? Not really. Those are my 2 options. Well, 3/6 plus 3/6, what does that equal? Let's check that out. I have 3/6 plus 3/6. When I add that up, that gives me 6/6, which is the same as 1. Those are all of my possible outcomes. I can only get one whole outcome, one whole probability. And that kind of takes me into the point that probability, I would write this down, because it's kind of important. I'll erase this so I have some room. Probability is always between 0 and 1. Probability is always going to be between 0 and 1. So a 0% chance of something happening is like it's not going to happen. Never. Well, 1, that would be like a 100% chance of something happening. That's like, it's for sure going to happen. No chance that it wouldn't. And then if we have something in the middle, like 1/2 or 3/6, that means that there's a chance that it could and a chance that it couldn't. It's equally likely. But we're never going to have a number below 0 or a number above 1. It's never going to happen. That's just the rules of probability. It'll always be between 0 and 1. So, if the highest probability we can get is a 1, and we look over here and we have our evens and our odds, and those add up to 1, that means 100% of the time I'm either going to get an even or an odd, which if you think about it is exactly what's going to happen if you roll a die. We call these complementary events, and that's another vocabulary word. So a complementary event, like evens and odds when you're rolling die, is going to be 2 events or more, could be 3 or 4 events, that all come up to equal 1. Those are your only options. They cover the whole sample space of everything that could possibly happen. So now, what is our next step? Well, if we're looking at this, I want you to kind of get in the mindset that it's not always going to be equally likely. Evens are going to be 3/6, odds are going to be 3/6. That's how it is with dice. But what if we have something that's a little bit more mixed up? Maybe there's a higher chance of one thing happening over another. So with dice, these are uniform models where everything is exactly the same. You're always going to get a 1, 2, 3, 4, 5, or 6, and it's equally likely that you could get any one of them. That is a uniform model. And it's uniform because it's all equally likely. But we have another thing, something else, called a non-uniform model. It's another vocabulary word right there. So a non-uniform model is something that's not equally likely. So we have an example problem here. We'll go with blue. So we have a bag of marbles. So we have one blue marble, two green marbles, and 6 red marbles. We have a lot of red marbles. So we're going to pull a marble out of this bag. There's 1 blue, 2 green, and 6 red. You can look at this right now and probably think, well, I'll probably get a red marble if I just reach in and randomly grab one. But let's see what our chances are. First of all, we need to figure out what the total number of marbles we have anyways is. So let's look at our total number. We have 6, 7, 8, 9. So we have 9 marbles. So I'm going to show you what we call a probability model. And that's going to kind of help you think about all your possible outcomes are and then what the probability of all those outcomes is. So, we have a probability model. It's going to be set up kind of like a table. So you're going to have, it's going to look kind of like that. That's how it's going to start being set up. So you're going to have your outcome on top. I'll write that in a darker color. You're going to have your outcome on top, and then the probability on bottom. I'm just going to shorten that because I don't think I could write probability in that space. So your outcome on top, probability on bottom. So let's list our outcomes first. So we can do blue. We could possibly pull out a blue. We could also possibly pull out a green. Or we could pull out a red. There are no other options, right? We can either pull out a blue, a green, or a red. Okay. So now, let's say we're reaching into this mysterious bag of marbles. What is the chance, what is the probability that I'll pull out a blue marble? Let's start there. There's 1 blue marble, so my number of times that it can possibly occur is only 1 time. So I'm going to start with my 1 and my numerator. But then how many possible outcomes are there? Well, there are 9, right? There are 9 total marbles, so I could possibly pull out any one of those marbles. So the number of possible outcomes is going to be my total number, which is 9. So there is a 1/9 chance that I will pull out a blue marble. Let's check out green. I want you to think for a second, write it down on your own about what the answer might be. Okay, so we have 2 green marbles. The number of times that it can possibly occur, I could possibly pull out 2 different green marbles. So I'll start with my 2 in my numerator. But I also still have 9 possible outcomes, right? Because I haven't pulled any marbles out yet. There's still 9 in the bag. So I guess 2/9 of a chance that I will pull out a green marble. You can probably guess where this is going. I have 6 red marbles, so I can pull out 6 different red marbles. So that's going to go in my numerator. Still only have 9 marbles left in the bag. So I have 6/9 of a chance to pull out a red marble. So this is a probability model, and it helps us look at, again, our outcomes. There are no other possible outcomes besides blue, green, and red, and then the probability of those. And if we count up those probabilities, if we look and see what they all add up to, that should show us that these are complementary events. So let's see, we have 1/9 plus 2/9 plus 6/9. So we have 1, 2, 3. 3 plus 6 is 9. So we have 9/9 of a chance to pull out either a blue, green, or red marble. 9 out of 9, that means that I got a 100% chance of pulling out a blue, green, or red marble. So I'm good to go there. So today we have talked about a bunch of vocabulary. We've talked about this really important formula, and then we've looked at some possible different models, uniform and non-uniform models, and then we've also talked about some probability models. Now this is just a super, super brief introduction to probability, and we will spend some more time talking about probability in the future. But I just kind of wanted to show you guys just a little bit so that you kind of get your taste buds wet before we go in, okay? Hope you have a super fantastic day. If you have any questions, feel free to ask down in the comments, and I will get back to them as soon as I can.